Have you ever imagined how the hot element coming out from the Earth? Before that, we must understand how Earth been construct. The internal structure of Earth is the layers of the Earth, excluding its atmosphere and hydrosphere. The structure consists of an outer silicate solid crust, a highly viscous asthenosphere and solid mantle, a liquid outer core whose flow generates the Earth's magnetic field, and a solid inner core.
Scientific understanding of the internal structure of Earth is based on observations of topography and bathymetry, observations of rock and outcrop, samples brought to the surface from greater depths by volcanoes or volcanic activity, analysis of the seismic waves that pass through Earth, measurements of the gravitational and magnetic fields of Earth, and experiments with crystalline solids at pressures and temperatures characteristic of Earth's deep interior.
Layer 1 is on an average 0.4 kilometers thick. It consists of unconsolidated or semi-consolidated sediments. Layer 2 could be divided into two parts. Layer 2A, 0.5 kilometers thick uppermost volcanic layer of glassy to finely crystalline basalt, usually in the form of pillow basalt, and Layer 2B, 1.5 kilometers thick layer composed of diabase dikes. Layer 3 is formed by slow cooling of magma beneath the surface and consists of coarse-grained gabbro and cumulate ultramafic rocks. It constitutes over 2/3 of oceanic crust volume with almost 5 kilometers thickness.
Earth's outer core is a fluid layer about 2,260 kilometers or 1,400 miles in height. The inner core was discovered in 1936 by Inge Lehmann and is generally composed primarily of iron and some nickel.
The concentrations of different volcanic gases can vary considerably from one volcano to the next. Water vapor is typically the most abundant volcanic gas, followed by carbon dioxide, 36, and sulfur dioxide. Other principal volcanic gases include hydrogen sulfide, hydrogen chloride, and hydrogen fluoride. A large number of minor and trace gases are also found in volcanic emissions, for example hydrogen, carbon monoxide, halocarbons, organic compounds, and volatile metal chlorides. The form and style of eruption of a volcano is largely determined by the composition of the lava it erupts. The viscosity, how fluid the lava is, and the amount of dissolved gas are the most important characteristics of magma, and both are largely determined by the amount of silica in the magma. Magma rich in silica is much more viscous than silica-poor magma, and silica-rich magma also tends to contain more dissolved gases. Please subscribe to this channel HBS News Info to know many new things.